Hi everyone, this is the video for week 3 of ACTSC231. We covered one really important topic this week, and of course we already got started on chapter 2 in the last class, so I just want to go over what we did. The topic that we introduced on Monday was the idea of a force of interest. Now, definition-wise, the force of interest at time t is just delta t, which is the derivative of the accumulation function a of t divided by a of t. So in that sense, you can think of it as an instantaneous interest rate for just an infinitesimal period of time, calculating the interest rate as we normally would. The amount of interest earned in that tiny little time period divided by the amount in the start of that time period. So that's where we get this formula. With compound interest, it turns out that delta t is actually a constant force of interest delta. So no matter where we are in time, the money is earning the same instantaneous rate of interest, which is one of the nice things about compound interest. And an even further interpretation of delta in the compound interest case is essentially it's I upper infinity. If we take money and we continuously compound it, then we'd end up with the nominal rate essentially being delta, or I upper infinity. We're taking the limit as m goes to infinity. And the relationship that's going to exist between this force of interest delta and the actual annual effective compound rate I is that next line there. 1 plus I is equal to e to the delta, or the reverse relationship, delta is just equal to the log, base e of course, of 1 plus I. So with the force of interest, we can sort of use it in two different ways. We can specify a constant force and then use it like any compound interest situation, or we can specify a non-constant force and use the reverse of this relationship to actually reobtain the accumulation function a of t and answer questions about that. On Wednesday we talked about inflation, so that's just a way of looking at the amount of purchasing power we have with our money, not just the dollar amount of money, but the amount in terms of how much stuff that money can buy us at some time in the future. So there's two forces that are at play here. Interest is causing the amount to go up in our account, but inflation is causing the actual purchasing power of that amount to go down. And obviously we might be interested in the real interest rate net of inflation in this sort of situation. And then last but not least, we actually started chapter 2 today on Friday, and the first thing we talked about there were equations of value. And this is just a way of setting up at any time t, so often we use time 0, the present value, but we can use any future time, and we take any cash flows that occur during this time period and either accumulate them to a certain time or bring them back to the present value at that particular time. And of course we just want to set the present value of the outgo equal to the present value of the income, or in other words, setting the net present value equal to 0. So with these equations of value, they're usually really easy to set up, and we looked at a couple of examples of solving for an unknown c, so an unknown cash flow at a known time, and also an unknown time. So we know all the cash flows, we just don't know when one of them occurs. So equations of value are really nice in that if we have one piece of information missing, we can use all the rest of the information in a single equation of value to determine that missing piece. So we'll continue with chapter 2 next week. Have a great weekend, and see you on Monday.